Welcome students to the chapter Haloalkanes and Haloarenes, and this is part 13 of this chapter for class 12. Today what we are going to discuss is preparation of haloalkanes from alcohols using phosphorus halides and thionyl chloride. So far we have seen how to prepare haloalkanes from alcohols using hydrohalic acids, isn't it? We have already seen in the first part of the preparation. The first part of the preparation we have seen how to synthesize haloalkanes from alcohols. So we will just go through it quickly in the next slide. Then we will see after that new methods to prepare using phosphorus halides and thionyl chloride. So first we will quickly go through the preparation using hydrohalic acid. So this is what we saw in the first part of the preparation. So in the preparation, while we were learning preparation, this is the first preparation that we saw for haloalkanes from alcohols. So the chloroalkanes can be prepared. Chloroalkanes can be prepared either by passing HCl gas or heating with constant HCl, or heating or treating with constant HCl and zinc chloride as the catalyst, which is called Lucas reagent. So in these three methods using hydrohalic acid, either by passing HCl gas or heating with constant HCl, or by treating constant HCl with a zinc chloride instead of heating, we can prepare in three ways. In two ways you can prepare bromoalkanes, that is 48% HBr, or heating with the sodium bromide and H2SO4, so a salt of bromine plus H2SO4, you can prepare bromoalkanes. For iodoalkanes, I have to use it's a salt, either a sodium salt or potassium salt, and 95% of phosphoric acid. So these were the methods that we used for the preparation of haloalkanes: chloroalkane, bromoalkane, and iodoalkane. So just to recollect it, I have provided the slides here. Try to understand it clearly. So once we have completed this, we will pass on to the part that is using phosphorus halides. So there are various reagents possible with phosphorus halides. We will see that first. So reagents can be either pentahalides, so phosphorus pentahalides. Then next is trihalides, phosphorus trihalides, or instantaneous inside the test tube. You can prepare red phosphorus plus halogen, a combination of red phosphorus and halogen. So red phosphorus is an allotropic form of phosphorus. You can either use red phosphorus and halides. So phosphorus pentahalides, for instance, can be used only for specific haloalkanes, trihalides for specific, and this combination of red phosphorus and halogens can be used for certain other combinations. So we will see one by one where will we use these reagents, in which haloalkanes will we use these reagents specifically. So here we will specifically see how the haloalkanes is prepared from alcohols. So first we will see chloroalkane. So chloroalkane can be either prepared from PCl5 or from PCl3. So among the three reagents that we saw in the previous slide, chloroalkanes are prepared either from pentahalides or pentachlorides or trichlorides. So PCl5, if I am using PCl5, what I will get is chloroalkane plus POCl3 plus HCl. So let us try to recollect, to easily remember this, to see a way to easily remember this. So what was PCl5? Last year and this year we have learned about PCl5. So PCl5 has a structure like this. So I hope you remember this trigonal planar plane. In the trigonal planar plane you have 3 Cl and 1 up. We have 1 Cl and 1 down. We have another Cl. So this constitutes this trigonal bipyramidal structure. Clear? Now what happens is during the reaction, this 2Cl will be replaced by O. 2Cl will be replaced. Remaining 3Cl will be there. This OH will be removed and this O will replace Cl. So what happens? You will get POCl3. Now the removed Cl, one of the Cl will go with R of alcohol and the other Cl will go with H of alcohol. So O will come and replace these 2 Cl and the Cl will take the position of O for R and for H. So you will get RCl and HCl, and instead of PCl5 we have now POCl3. Clear? In the second case, here you can see there is 3 chlorine. So what we have to do is, though I have not shown here, actually in the reaction I will write it. There are 3 molecules of alcohol plus PCl3 will give 3 molecules of chloroalkanes plus H3 phosphorus acid. So this acid is phosphorus acid. Clear? So what is happening? The entire OH is removed from here, and we will first try to draw the structure of PCl3, then it will be more clear. So we have phosphorus and we have a pyramidal structure for that, PCl, PCl, PCl. And in the case of ROH, we are using 3 ROH. OH from each group will come and replace chlorine from here. OH from each group will come. So let us see what happens if they are replaced. So in the case of phosphorus, we have OH, again OH, and here OH. So what is this compound? This is H3PO3, H3P phosphorus acid. Clear? So since this is acid, and in each case when OH is removed, its Cl that is being lost here will get attached to haloalkane. So this is how to get chloroalkane from alcohol. So these reactions will happen generally whenever you are using PCl5 and PCl3. So in every time when you are using PCl5 in organic chemistry, such a type of reaction is happening. So in the first case, only 2 chlorine will be removed. In the second case, the entire chlorine is removed by the OH as such. In the first case, only O is involved. In the second case, OH is getting attached to or is replacing chlorine. So that's about chloro. Next, how to prepare bromoalkane. Again, I can use PBr3. So it is a trihalide of bromine, or I can use the third reagent that we saw in the previous slide, which was a combination of red phosphorus and halogens. So here I have to show only the product. You don't have to show the byproducts. For example, phosphorus, you just have to show only the product, that is RBr. And in the case of tribromide, it is the same way to remember RCl. So as I said, whenever you are using trihalide, you are always getting, or you have to always remember the method that I show you. So in this case, the only difference is that I will draw, we have phosphorus, but what we have on the base is bromine. Instead of chlorine, we have bromine. And what happens here? There is 3 molecules of and you will get 3 molecules of RBr. Molecules of alcohols are the 3 molecules of alcohols, and in each case OH will come and replace bromine, and each bromine will get attached to R. So this is not provided, this balanced equation is not provided for you in this slide. So if you like, you can write it, you can note it down in your notebook, or when you get these slides, try to write on the slides. So it is not just RH, it is 3 ROH, and you will get 3 bromoalkanes in this case. Okay. Generally speaking about the balancing in organic chemistry, balancing is not important unless otherwise it is specified. Okay, balancing atrayum important alla, specify cheyidittundu, otherwise in certain reactions it is important to show balancing, because the stoichiometry, if it is altering the reactions, then it is important. ഏതെങ്കിലും ഒരു റിയാക്ഷന്റെ സ്റ്റോഷിയോമെട്രി മാറ്റിയാൽ, if there is a change in stoichiometry, if the product is changing, in that case balancing is important. Otherwise it is not that important to balance, and sometimes it is not also possible to balance. So such an example is this one: red phosphorus plus Br2, you will get RBr. It is not balanced and it's not possible to balance because there are lot of unspecific products formed. In the case of iodoalkane, only the third reagent can be used, that is red phosphorus plus I2. So you'll get Ri, just like RBr you got. So for preparing haloalkanes from phosphorus halides, for chlorine, generally there are three reagents as we saw: pentahalide, trihalide, as well as red phosphorus and halogen. So for chlorine we will use first two, for bromine we will use last two, and iodine we will use the last one. So that's the order. PCl5, if you are using PCl5, you will get POCl3. If you are using PCl3, you will get 3 molecules of RCl and phosphorus acid. PBr32, it is like that, 3 molecules of RBr and H3PO3. In the case of iodine, you will get red phosphorus and iodine. In bromine also you can use red phosphorus and iodine. So if you can have this image in your mind, you can clearly always remember the methods of using or preparing these compounds. So they will not ask for you for different methods. Sometimes they may ask like convert using this compound to this, maybe directly or indirectly. Okay. So we have already seen now hydrohalic acids and phosphorus halides. Next what we are going to see is thionyl chloride. So thionyl chloride has a formula SOCl2. SOCl2, sulfur, oxygen and 2 chlorine atoms involved in the molecule. And it has a lot of significance in the preparation of haloalkanes. Let us see what are they. So from alcohols using thionyl chloride. So it's very easy. When you are using thionyl chloride, what happens is it will give one chlorine and it itself cleave into SO2 and HCl. So it will directly replace OH with Cl, and the resulting products are very important. What you are getting is SO2 plus HCl, and if you look into their subscript, you can see the byproducts are both gases, whereas this one remains in the test tube. So when you are using alcohol plus SOCl2, you will get RCl along with 2 byproducts, sulfur dioxide and HCl, which are gases which will be removed from the test tube by itself because they are both gases. Clear? So thionyl chloride is preferred reagent. Why? Because the products formed other than RCl are escapable gases. They can easily escape from the test tube. So if you want to prepare RCl in its pure form, that's the important thing. RCl obtained will be pure. Which will be the reagent you will be using? So far we have studied about hydrohalic acid. we have studied about phosphorus halides. So which one we will be using? The last one, that is thionyl chloride, because the byproducts formed here will escape by its own. So the obtained RCl will be in their pure form. So that's the reason this is the most preferred method if you want to get the RCl in pure form just by adding a reagent. You're just adding a reagent, you don't have to remove anything, you will get RCl in its pure form or purest form. Not exactly pure, but in its purest form you will get RCl in its purest form, because the byproducts formed SO2 and HCl are escapable gases. So let us look into the summary of this part. That is, we have already seen hydrohalic acids, and in the case of hydrohalic acids we have seen the different methods. In each case, like for chloroalkanes you have specific methods, for bromoalkanes there are 2 methods, for chloro we have 3 methods, for bromo we have 2 methods, and for iodic, in the case of iodoalkane, we have 1 method. Clear? With a 95% of phosphoric acid. In the case of phosphorus halides, there are 3 basic reagents possible: pentahalide, trihalide, as well as red phosphorus and halogen. In the case of chlorine, we can use penta and trihalides. In the case of bromine, we can use trihalides or tribromides, phosphorus tribromide, as well as red phosphorus and bromine. In the case of iodine, I can use red phosphorus and iodine. For thionyl chloride, it is the most preferred method if you want to have pure RCl. Just add a reagent. What you are getting is the purest form. Not 100% pure, but it is the most purest form of RCl that you will get. Okay, so that's all about the preparation of haloalkane from alcohols. This is how to prepare that. Okay, thank you.